get into our second example for the mean or average value theorem for integrals. It says the temperature in Celsius at time t in hours in an art museum varies according to the following formula. So we have capital T, which is our dependent variable, in temperature in Celsius, and little t, which is our independent variable in hours. So it's equal to 20 plus 5 times cosine of pi over 12t. So, for example, if you were to plug in, say, 3 in for t, that'd be after 3 hours, right? This would cancel and become pi over 4. Cosine of pi over 4 is square root of 2 over 2. You'd multiply it by 5 and add 20. And that would give you the temperature inside the museum after 3 hours. So, this question is asking, find the average temperature after 1 day. Average temperature, right? So, in other words, if we were to just think about being in this art museum for 24 hours, the temperature is going to change based on this formula, right? But what would the average temperature be? And this is where we start to see the application of average value. At any given point in time in a 24-hour day, what's the average temperature? And this isn't just for inside of an art museum. You can find data like this if you look at the average yearly temperature of a city or something when trying to determine whether to move there. Some people like warmer climates, and that's a important, relevant piece of information to know before you move somewhere. So the first thing we're going to do, just like in the last example, follow step 1, label the interval a to b. Well, it says after 1 day, right? So this is actually pretty simple. We're going to start out at time t equals 0, so 0 hours, and there's 24 hours in a day. So we're going from 0 to 24. Very simple. So therefore my a is equal to 0, and my b value is equal to 24. Step 2, write out the formula. Okay, so what's the formula for average value? It's 1 over b minus a, and again, I've already shown a proof for this, so if you want to go back and watch that video, help yourself. 1 over b minus a times the integral from a to b of f of x dx. Very easy to remember in my. So once we've written out the formula, we're going to plug this stuff in, f of x, a, and b, then we're going to figure it out. So remember, b is just 24, since there's 24 hours in a day. A is 0. And then f of x was the formula that was given to us up here, so I'm just going to write that out. 20 plus 5 cosine of pi over 12t. And since it's in terms of t, I'll just write dt and make sure I copy that correctly here. Oops, too far. Okay, yeah. So that will give us the average temperature in this museum from after the first day, or from 0 to 24 hours. And so for step 4, all we have to do is determine the definite integral and then multiply by 1 over 24. Okay, so how do we integrate this function, or how do we find the antiderivative? Well, we will be using, you can use u substitution, or you can just kind of use some insight and realize that the antiderivative is going to be some sort of sign, except we have to take care of this constant when we rederive it. So I'll go ahead and do that real quick, and we'll go back and talk about it. Okay, so in order to integrate this, what I did is I made u equal to pi over 12 times t, so that I can take the antiderivative. So du dt is of this would just be pi over 12, okay? Just the constant in front of the t. So therefore, if I multiply both sides by dt, I get du is equal to pi over 12 times dt. That might be a little faint for you, so let me fix that. It was an older lesson that I'd done, but I decided not to rewrite all of that. No point, right? And so if I get dt by itself, I would multiply by the reciprocal of this, and I'd end up with 12 over pi du is equal to dt. Okay, so when I go to integrate this, I do have now my u. I said u is equal to pi over 12 times t, right? So we just determined, though, that dt is equal to 12 over pi du. So dt is going to be replaced with that in my formula. So dt is being replaced with 12 over pi du. Now, if you've followed along correctly in the flow of calculus, you know that these limits have to be changed because they're in terms of t. They need to be in terms of u. So we do a little fishy, I like to call it, right? Before we do that, actually, this 12 over pi, we can basically move all the way to the front of the integral, okay? So you can see 12 over pi times 1 over 24 is just going to be 1 over 2 pi. That's how we get this right here. So we're moving that original dt that we replaced out to the front since it's a constant. So 12 over pi times 1 over 24 is 1 over 2 pi. And then now, again, these are in terms of t. We cannot have them in terms of t. All right, they need to be in terms of u. So what we're going to do, since this is in terms of u, we're going to convert our limits. Okay, and use our original u equation. U is equal to pi over 12t. So we're going to be plugging in our t values in for t right here to get new u values back. Okay, so let's go ahead and do that. So these should be in terms of u, since our formula right here is in terms of u. So if we plug in, for example, 24 here, we get 24 over 12, which is 2 pi. So our new limit is, upper limit is u is equal to 2 pi. For the lower limit, if we plug in 0, we're going to get 0 back. So it stays the same for the bottom. So for the bottom, we have u is equal to 0. And for the top, we have u is equal to 2 pi. Okay, so now we have the proper integral from 0 to 2 pi. And those are in terms of u now, so we can check that off. And don't forget the 1 over 2 pi that we originally simplified after we pulled the dt substitution out. So we have 1 over 2 pi times the integral from 0 to 2 pi of 20 plus 5 cosine of u. Now this is something we can antidifferentiate, right? Because integral or antiderivative of cosine is sine. The integral of this is going to be 20t, and the integral of this is going to be 5 cosine of t, and then we just evaluate it. So that's what we're going to do. Okay, so integral of 20 is 20. I said 20t, it should be 20u because these are in terms of u. So we get 20u plus 5 sine of u because the integral of cosine is sine. Okay, and since we changed these in terms of u already, we don't have to do anything else. That's why I like to convert my limits in terms of my u substitution. We're just going to plug in 2 pi into this formula and then subtract when we plug in 0. Figure all that out and multiply by 1 over 2 pi. It's going to be 20 times 2 pi plus 5 times sine of 2 pi minus 20 times 0 plus 5 times sine of 0. Okay, so continuing along, this is going to give us 20 pi. Now sine of 2 pi is 0, so that just becomes 0. 20 times 0 is 0. And then it's minus 5 times sine of 0. But sine of 0 is just 0. So the last three things are just equal to 0 here. The first thing is 40 pi. And remember, we have the 1 over 2 pi out front, so it ends up being 40 pi over 2 pi, which is just equal to 20. Crazy, right? And then since this is a word problem, we're going to answer verbally. And this might not be very legible to you, so I'm going to go ahead and read it to you. The average temperature in the museum for the first day was 20 degrees Celsius. So, going back to the context of the problem, you know, we had, here was our original formula. Let's go back to what I typed up here. The average temperature in the art museum is given by this. Okay, so if we were to calculate this thing for the first 24 hours, the average temperature is going to be 20 degrees Celsius. Now, that doesn't mean that it's always 20, right? It's probably going to be cooler or hotter depending on the time of day, but if we average all those temperatures together using our average value formula, we get the average temperature is going to be 20 degrees Celsius inside of that museum. That's it for this particular example. If you have any other questions about it, let me know.